how to make it sustainable while keeping all the other things. Have it affordable, have it safe, etc.
And do you think we're doing a good job, or?
Yes, we are, but we're not going fast enough.
If you prepare for the current job, you are preparing for the last Olympic Games, the ones that already were there.
Yeah.
And that is a mindset that has to change.
In this first episode, we start with a question that feels simple, but is anything but simple. How do we make aviation more sustainable without stopping the system the world depends on? Because aviation isn't something you rebuild overnight, it's shaped by decades of engineering, infrastructure and decisions. I'm joined by Joris Melkert, head of the educational program within the faculty, and Rinze Benedictus, full professor within the Department of Aerospace Structures and Materials. Together we explore what it really takes to shift a system like aviation, where innovation starts, where it slows down, and what needs to change to move forward. Let's get into the conversation. Welcome Joris and Rinze to the podcast. This is the first episode, and my first question of this episode is, how do you drink your coffee? I think I will start with Joris.
It's very empty, I would say. I don't drink coffee. I don't drink any coffee anymore. I drank coffee when I was in high school, and when I was a student, it got less and less and less. And then somewhere in the evening, I had a meeting, and then I drank a cup of coffee. And the day after, I felt very sick. And since then, I stopped drinking coffee.
Okay.
I had no reason, no link with the sickness or so, probably a flu or something like that. And since then, I think I drank coffee twice or so. One time when I was on my internship in Syria, in Damascus. I'm the one and only student who did an internship in Syria. And then they offered me a Turkish coffee, but you couldn't refuse because it would be very impolite. Well, I was awake for 24 hours.
Yeah. And now you drink tea or just water?
Tea and mainly water.
And you, Rinze?
Nowadays I drink it black.
Yeah.
And I can't live it. I mean, in Dutch I call it arbeidsvitamine. So I start my working day with coffee. And if I don't do it, something is missing. And maybe that is also, I drank coffee since I was a kid, I think. I don't remember when I started. But I drink it in every shape. Let's say with milk, with sugar.
Okay.
Especially when I was a kid. Nowadays, if there is milk in there, I tend to leave it. If there is sugar in it, more preferable not.
No, just
but
black.
It has changed over the years.
Yeah, okay.
But coffee, without coffee, no. That is
There's no start.
It's a headache.
Yeah.
It's a typical headache you have at a holiday when you get less coffee than you're used to. And it takes a couple of days till you have found your source of coffee again.
Yeah, and the headache becomes, you get the headache because your body is addicted to the product you need. So that's, that's. So my second question will be, can you introduce yourself in one sentence?
Okay, that's simple. It's only part of life, so to say. Actually, I do two things. I'm an associate professor in the flight performance and propulsion chair, and I'm the director of education of the whole of the faculty.
Yeah. And for you, Rinze?
Yeah, I'm nowadays, again means here, I used to be more in the management, but now I'm a full professor, officially Aerospace Materials. I really enjoy it when I see others blossoming based on something that I started.
Okay.
So I need some kind of involvement.
Yeah.
I do. I want to feel proud as well, and that you can be proud if you have some involvement, I think. But I don't need to harvest. If others harvest, it's wonderful.
Yeah, that is satisfying for you.
Oh yeah.
Yeah. And on the technology side, I think it's a question for you both. Why is it so hard to produce an aircraft? To make an aircraft?
Define an aircraft. What is an aircraft for you?
For me, it's like a tube, a cigar with wings on it, and you get on that aircraft to go on a holiday.
I would answer the only thing you need is a garage and some tool. Everybody can do that. I mean, it's proven. I mean, go to back in history, where people behind the Iron Curtain, that's a long time ago, but they make aircraft with lawnmowers, and they flew over the Iron Curtain to the west. I mean, it shows that you don't need much just to fly. The problem, or the real issue is, make sure that you, as the builder of the aircraft, guarantee that somebody else you don't know, in circumstances you don't know, can use the aircraft for 30 years without any problem. And willing to put your signature under that document. That is the challenge we have.
And then you end up with one of the most complex machines the Earth has ever known, the world has ever known.
Can you elaborate a bit more about that, Joris? Why is it that
it's the circumstances. You go from very warm to very cold, from the heat of the desert in the summer until cruise altitude in the winter over the Arctic. So from plus 40, 50 degrees centigrade to minus 80 degrees centigrade, where materials start shrinking and expanding. You go in an environment from oxygen rich like we have on the face of the Earth till where you just literally die within the 5 minutes because of lack of oxygen at altitude. Temperature wise, inside the cabin needs to be nice. It needs to be safe in all circumstances, in hard landings and bad weather conditions. And add that all up, you have about 100 systems on board that all need to function perfectly.
And I think we fly for 120 years. So in the lifespan of, say, humankind, that's very short, right? But in my opinion, technology goes very fast. So where are we in, let's say, technology? If you look at the aircraft today, what can we expect in the coming, let's say, 10 years on technology?
Gradual steps. Don't expect major leaps anymore. It's just a combination of all these technologies that need to work perfectly together in harmony, I would even say. But the big steps have already been taken. Big steps going from wood to metal to composites, going from propeller engine, piston engines to jet engines. That's the big step. It's now more make it affordable, make it reliable, make it safe.
What is the biggest challenge right now? Number one challenge?
Number one challenge is how to make it sustainable while keeping all the other things. Have it affordable, have it safe, etc.
And do you think we're doing a good job, or?
Yes, we are, but we're not going fast enough. The issue is every year, on average, an aircraft in the fleet gets 1% more fuel efficient, gets more silent. But aviation grows by 3 to 4% per year. So we have a diverging problem. We, as citizens of the world, will continue to fly more and more. The moment we get more wealthy, we'll start flying more. You see that now, especially in Asia, China, India. But imagine many people in Southern America still have to start flying. Africa's coming. And if you do the statistics, it's about 85-90% of the people on Earth who have never flown yet. It's going to happen.
So it's only 10 to 15% of the people who have access to an aircraft.
At the moment,
So there's a big challenge. So what are the solutions currently available to make that flight more sustainable?
Well, the bad news is there is no silver bullet.
No.
The good news is there's many things we can do still. That's why we still have a job, I would say. But think about better aerodynamics, so you use less fuel. And the most sustainable fuel you have is the fuel you don't need to use. Lighter structures, more efficient engines, weight reduction here and there. It's all tiny bits and pieces. And of course, sustainable fuels.
Yeah, and Rinze, you have a background in aircraft materials.
Yeah.
Do we do enough there in the last 10 years, or should we catch up, or what is the big win from the material point of view? Structure.
I mean, we is a big word then. I'm an aerospace engineer, that type of we. I'm an academic, that type of we. I'm just a Dutchman. There's many we's that I'm part of. Do we do enough? I think in academia, we're still looking for the silver bullet. I think that in academia, that's not a problem. You can do that, you can dream. Do we do enough? I think there is not much at the horizon at this moment that I can claim that material will give us the step we need. Yes, we do have composites, we have metals, even wood is used today even still. There are many places where we know what material of the current materials are the best. We can probably describe to some extent what material we would love to have, even that is already difficult. We have no clue yet where we will find or how we will develop those materials. So what we do is at this moment is really focusing on, let's say, existing materials, existing properties. Can we make those materials in such a way that they are reusable or that we can give them back to nature? So that is what we focus on. But that's not enough to make aircraft itself green.
And what is currently being done with aircraft that are out of service?
Depends on, and if it is metal, then it's mainly aluminum, and there's a lot of steel in the landing gear. If there is titanium, maybe, but the majority, maybe not volume, but no, it's aluminum. You can store it. I mean, that's aluminum is a metal that is almost reused 100%. It has a high value, and the reason for that is quite simple. Once you have it, it's relative to steel and others. It needs less energy to rework it into a new product.
Okay.
So that's why it has high value in recycling. It also means that in an aircraft, if you can store it in a desert, dry place, that means you can reuse the parts. Well, that's been done. As long as the model is being flown, you can reuse the parts. If it is totally not reusable anymore, in that sense, then you recycle it. There's value in it.
Yeah.
Not much, but there's value. If you go to composites, it's a different story.
Okay.
We don't have proper solution for recycling of composites. Again, in the lab of universities, you will find solutions. But so far, we have not found a solution that works on economical scale.
And what is needed to go from that step from a lab perspective in a university to the real world?
What it first needs is it's a system. So there is not a point solution in that system that will suddenly make it happen. That's how we typically approach it. And not only being academic, but that is how funding works. You go for a point solution, you oversell it, and then the system will change. And at the end, it hasn't. Because the system doesn't change. The system has its own equilibrium. It becomes philosophical. No. And it will get back to its equilibrium. So if you're not willing to have a systems view on it, it will never change. Unless there is a disaster happening. But you don't want it. Because a system that is out of control, you have also no control of what the outcome will be.
And do you have an example of technology that was ready to implement in that system, but it did not work because of that equilibrium was not in the right place?
Let's say the carbon composites.
Yeah.
Or even glass fiber composites. We use glass fiber composite in a huge quantity already for quite some years. Windmills, for instance. We don't have a real solution what we do afterwards. So what do we do nowadays? We grind it and we add it to cement, the beton.
Yeah.
And in some cases it makes the cement better. In some cases it doesn't, but at least we get rid of it. If you're not aware of everything, if we condemn that type of things that has been done or decided 40 years ago, 40 years in time ahead, people will look at us as well. Why did they make that choice? Didn't they know? No, we didn't know. We don't know everything. We make today even wrong choices as well that have consequences for the future. It doesn't help, in my opinion. We do that a lot in the Western world, condemning the history. That everything, we don't know everything. Even today we make mistakes.
No.
What is the real things? Look ahead. Don't look back. Don't blame.
Yeah.
But look ahead and change.
But it's difficult, right? Because we can learn from the past.
Yeah.
And it takes some balls to look into the future.
And it will cost a lot of money.
Yeah.
And maybe money is the wrong word. It costs a lot of resources.
Yeah.
So it needs people with vision, but also people who dare to take decisions and be patient.
And do you think, maybe that's a question for yours as well, as chief education boss at the TU Delft, at our faculty, do you see there's a change in the educational system from the last 10, 20 years towards the students now, what we teach them?
To a certain extent. And in addition to what Rinze said, I think we also need the people who do that, and we need to train them accurately. They need to be knowledgeable. What we see in students, they are a bit more focused on sustainability. However, if we organize a dedicated lecture on sustainability, they don't show up. So it's a bit of a...
And do you know why?
I don't know, maybe because it's not compulsory, not part of the exam, or
The wrong time.
whatever.
Yeah.
But we're revamping our bachelor curriculum, and there we'll give more attention to these kind of things to make it more visible.
But
But I think student-wise, the attention of students towards sustainability is definitely much higher, I would say, than 20 years ago.
yeah,
Whether we implement that in our curriculum in the right way, I doubt it.
yeah. And what kind of mindset would we teach these new students for this, let's say, future system? What is important?
Well, that's an interesting question. Since we're revising the curriculum, we asked that question many times, many locations. What should we teach? And then you see coming up, of course, the basics, the fundamentals every time. And one thing, and then of course we have courses on the fundamentals, the mathematics, the physics, etc. And one thing that comes up everywhere, but not only in our country, also all over Europe, is critical thinking. That comes up every time. And then I started investigating, is there anywhere a university in aerospace engineering or engineering that teaches critical thinking? The answer is no. I have not been able to find a course on critical thinking. So the question is, how do we teach that? I don't have the answer yet, but it's an interesting question.
Is that critical thinking more connected to the attitude of the student, or can we teach critical thinking?
Well, that's what I'm wondering. Can we teach that?
Well, what do you think?
Somehow it comes. Maybe it comes naturally. And maybe another important skill that's much overlooked is the ability to learn, because we are able to form and shape our students for 3 years in a bachelor, 2 years in a master, and that's it. Maybe a PhD, but after that, they go into society.
Yeah.
And they have to be working there for 40, maybe 50 years. And I know for sure that the jobs we have now are not the jobs of the future. The jobs of the future don't exist. We can even think about what the jobs will be.
No.
But still, they need to be able to acquire new skills. They need to be able to learn. So the skill of learning to learn is maybe even more important than critical thinking.
Yeah. And in general, if you look at aviation, implementation of a new innovation takes a long time, right? So how can we prepare these students on the sector or on that job?
I doubt whether we can do that. This comes with experience, I would say.
Yeah.
And here and there will be some disappointment. And I think in aviation things go even faster than in space. If you work on a big satellite, it's a lifetime thing.
I mean, preparing for a job has a risk in it as well. Eh? I mean, we just had the Olympic Games.
Yeah.
And what is the Paralympics or the regular Olympics? It's impressive what those people do, what they are able to do. If you prepare for the current job, you are preparing for the last Olympic Games, the ones that already were there.
Yeah.
The one who does slightly different things is probably the one that gets the next medal.
Yeah.
Not the one who is preparing for the last Olympic Games. And that is especially with academic teaching, we have to remember, we have to train people for the future, not for today, but what is needed in 5 or 10 years.
Yeah.
We don't have always that answer. So yes, I think it's much more about skills than about competences.
Yeah.
Yeah, you need. Yeah, I don't know exactly.
It's a combination, because you need the basic, you need the mathematics, the physics, the aerodynamics,
of course,
etc. But 40 years ago, we didn't know about CFD, computational fluid dynamics, aerodynamics in the computer. You don't need to ring the bell. I'll explain. And now we do that massively. But still, the engineers of those days are still able to do that. They have acquired the skill to learn new things and be critical on the outcome. That will come.
I think most teachers today that teach artificial intelligence, whether it's at high school or whatever, never have learned artificial intelligence at school.
No.
It shows that we can develop.
Yeah.
It also shows that what you have been taught today, I fully agree. If there is no basis, then you can't judge. So there needs to be a fundamentals.
Yeah.
There need to be. But we should not over-exaggerate it. What we not should do is train that one single student to be a perfect fit with one industry or one professor. That's the other thing that we tend to do.
Yeah.
The professor that shouts the loudest typically gets... No, we built a program towards that person.
Yeah.
We should not do that. We should have a vision. We should, in my opinion, be able to phrase a vision. This is needed in the future. And that is not a very satisfying vision because we are not very concrete there. We also don't know. And
for that vision, do we look at industry? Or how do we because we don't have a glass ball to look in the future?
We look at all.
Partly, yeah.
Industry is one of the buzzwords, stakeholders, one of the parties that play a role.
Yeah.
It's society. Society is big. And there's all kind of different stakeholders in society, and we should consult them all.
Yeah.
It's not something you can do tomorrow. I mean, take the time for these things.
Yeah, so that would be my question. Where should we be patient, and where should we accelerate on fields of research or topics?
Well, since everything is connected with everything else in aviation, you need to excel and accelerate on all areas and see where you get.
And can you give an example from the past?
Maybe the very nice example is the Wright brothers. They made it happen for the very first time. Powered flight, glider flight did exist by then. Otto Lilienthal, these kind of famous persons started mastering that. They started mastering things like flight control. They started mastering aircraft structures. But what was missing was the engine, which was powerful enough and lightweight enough to get it into the air. And only when you had that combination, and the Wright brothers managed to do that, they could then take off.
And what was key in their invention?
Well, the combination of to make it work together.
Yeah.
The aerodynamics, the ideas they built their own wind tunnels even.
Okay.
The knowledge about engines and drives and control, flight control. They designed a catapult to launch the aircraft. They had the view on what type of weather you needed. They specifically transported the aircraft to a place where they had a lot of wind in Kitty Hawk, North Carolina.
Yeah.
They didn't do it in Dayton, Ohio, where their workshop was, but they moved the aircraft to find a place with a lot of wind. So they more or less got a grasp of what all you needed, and it all needs to work together.
Yeah. And do you think nowadays the innovation is slowing down or speeding up? If you look at the current state of aviation, because we're talking about hydrogen power, electrical battery flight, maybe a different shape of the aircraft.
Well, I think there is a lot of innovation going on, but making the step from technology readiness level TRL 0 from the first brain spark to 9 when it's flying in a commercial aircraft, that has become harder and harder and harder over time because we want it to be safe as well. We want it to be cost effective.
And why is it so hard?
To be the devil's advocate.
No,
I mean, what you call innovation, the different shape is pre-World War, the Second World War. So that's about, not just about 100 years. I think, I'm not sure.
So you
when
mean
it started.
We tried it already?
We work on it already. Hydrogen, the Russian flew with hydrogen aircraft.
Yeah.
Others apparently as well in the past.
Yeah.
Electric aircraft fly already, smaller aircraft, but they fly around.
So why is it so hard to implement it, let's say now? Because these are hot topics. If I open the news, electrical flight, two persons, 4 persons.
Well, it's just not good enough in the whole system. For instance, hydrogen, you can make an aircraft fly on hydrogen.
Yeah.
But where do you get the hydrogen? How do you make sure that in every airport there's hydrogen? If you fly from Amsterdam to Singapore and there's no hydrogen in Singapore, you're stuck for the rest of your life.
Mm-hmm.
Maybe a good place to get stuck, but it's the system. So that's why the systems view, the systems engineering is also very important.
And getting back to one of your, I think patience is needed because we don't have the system has to change.
Yeah.
And that's on all aspects of the system, things will change then.
Yeah.
That takes a lot of resources to do that. We can't afford that. Not doing that in 1 day or 1 year. It needs multiple years. That needs a society that is willing to have that vision that it has to change and be patient, in my opinion. If you demand a change in the next 5 years or the next 10 years, it's one big disappointment.
Yeah.
And the result will be do a lot of research where it's fundamental or applied. Nothing will be applied because the system can't adapt it. And everybody is pointing at everybody what they did wrong and spent wasted money or resources.
Mm-hmm.
If nobody stands up, let's say if Europe doesn't say, okay, this and this is what we want, and we are willing to spend resources and we are patient, and in all honesty, 2050 in aircraft is not being patient.
It's tomorrow.
It's tomorrow.
Yeah.
It's really tomorrow. It's the next generation of aircraft that is tomorrow.
Yeah.
So don't expect that we have solved everything in 2050. I mean, yes, I would love to. as an academic, I'll go for that because I can dream. As an academic, I can dream. If I would work at Airbus, I can't dream. Then I risk the whole company. Then I risk the jobs of 100,000 of people.
Yeah.
I can't dream.
So other factors are in place there.
I also have to acknowledge that other factors in that same have a different way of acting. But that's why we need to be patient. Give them space. Give them time to adapt. And at a certain time, I think it will change.
But so you can dream.
Yep.
So can you maybe share a bit of that vision from your point of view?
Let's say my dream starts with that we have one world. Yeah, we have one world. We should be, but one world, and then I'm talking about people that know each other, that can meet each other, and that involves long distance traveling. Meeting somebody sitting behind your television doesn't work. Or reading in a newspaper, or reading a book, or going on holiday even. It's not meeting. That's staying in your own bubble and making your own judgments. You are not confronted with the other.
No.
So only if you meet the others, you are confronted. You have to change. Otherwise, there is no interaction.
No.
So we need to meet. That needs long distance traveling.
Yeah.
Whether we fly or what, if we want to do that in a certain time, it takes a lot of energy. Whether it's aircraft or train, it doesn't matter. It takes a lot of energy to facilitate that.
Yeah.
So the real thing is we need green energy. We need a sustainable source of energy. And we don't have that. There is more than enough energy available. What comes from space to us is more than, I think, is it 100 times or 10 times more than we ever need?
A couple of thousand times. Even.
Yeah, so it's enormous what comes to us.
Yeah.
We should try to harvest that. Is hydrogen the solution? Well, currently it will probably help. I think that even nuclear energy, not for aviation, but in the bigger picture, it is a short-term solution. It's not a solution in 1,000 years. But to get to that 1,000 years, we have to make steps maybe that are dead ends at the long term, but at the shorter term, they help us.
Yeah.
And that's also in aviation. I think the next engine is probably a hybrid engine. Because when it's hybrid, electric with kerosene, I think, maybe hydrogen.
Yeah.
But it's not a green engine yet. And that's not failure. That is
but
the first step.
It's the road too.
It's the road too.
Yeah. So maybe a question for you, Joris, to make the bigger picture of aviation in terms of CO2 emission or pollution or sustainable aviation. Can you, how big is the impact of an aircraft or the aviation sector? Can you elaborate a bit on that?
It depends a bit on who you talk to, but if you look at the CO2 emissions and compare it to the worldwide CO2 emissions from fossil fuels, you're talking 2 to 3%. You also have the so-called non-CO2 effects, things like the contrails, water vapor, nitrous oxide. There it's a bit more difficult, that it depends on the place where you do the emissions, the time of year, the time of day where you do the emissions, but that can go up a multitude.
So contrails are these like stripes behind
the
an
white
aircraft?
stripes behind, you don't see them every day. They're relatively easy to avoid. You create them when the air is cold enough, and so you can also find places where it's warmer and where the combination of moisture, etc., is better suited. Working on that as well, but that percentage is larger.
So you say the impact of aviation, let's say 2 to 3%.
Yeah, for the CO2 only. Yeah.
Yes, and compared to other sectors like road transport, or I don't know if you know that, or shipping industry.
Road transport is I think 10% or more. One very interesting one is clothing industry. 10% or more.
So why
shipping 3 to 4%? I think.
So I think clothing is a nice example. Why do we see in the news that aviation is, let's say, the bad guy, and I don't read about the clothing industry being polluted?
Yeah, I don't know. The spotlight is on aviation.
Yeah,
and that's good because that makes us feel the pressure to make changes. But in the global scale, it's not significant, but it's not the major player.
And why you think the spotlight is on an aircraft, on aviation?
Good question. Maybe it has to do with that it's for the rich and famous. That's where it started. The wealthy people, because it's still what we said already earlier. 10-15% of world population has flown. The rest has not yet flown.
No. Do you think we should change that perspective as well? That we only make flying available for the happy few, or should we?
Well, there could be reasons for that. You could say, well, we know that aviation gets better, gets more fuel efficient by 1% per year, and then it means you cannot afford a growth of 3 to 4% per year.
Yeah.
On the other hand, as long as people have the money and they have the time to start traveling, they will travel. That's the course of history.
And it's also a bit of a contradiction in my head that we say we need to fly less, but if you fly less, we produce less aircraft. So innovation is also slowing down.
That's the other discussion you have. There's also think papers from Eurocontrol about that. In order to make aviation sustainable, you need to earn money. You need to be able to pay it. And flying is by now a very marginal business. Think of the average profit on the sales of one ticket from an airline is less than 10 euros on a worldwide scale.
Yeah.
America a bit more, Europe a bit less, Africa it's even negative on the average. But with that 10 euro, you need to pay all your innovation. And that drives to a conclusion which says you need to fly more to be able to pay that innovation. And that's a very weird conclusion. You don't want to do that.
And Rinze, how many aircraft are produced worldwide per year?
1,500.
Yeah.
1,500.
It's about Boeing and Airbus. That's about the size.
Yeah, then
and a few smaller.
So that's not a lot compared to if you look at the car industry or the train industry.
It depends. What do you mean with a lot? If you count the amount of hours we need for that, the amount of people working on one aircraft, it's an enormous effort.
Yeah. You just think of Boeing and Airbus and the factories of the 737 or the A320 derivatives. They produce 2 a day, and these machines have a value of more than 100 million euro a piece.
Yeah.
Think about the logistics to get that arranged. 2 a day.
Yeah. Yeah, that's good to think about.
So it's more than ASML produce per year.
Yeah. How can we scale that?
Very big question.
That's why I'm asking it here at
that's why
smart people.
That's why production engineering will change. It used to be once a week, once a month, and now it's multiple per day, and that changes the way you go more towards series production than just single pieces. And how do you scale up that production?
Yeah.
How do you scale up composite production? How do you keep it affordable? If you say, well, composite is a nice thing to do, it's a lightweight, it saves fuel, etc.
Yeah, Rinze.
I still think if you scale it, let's say the 1,500 a day. So that's 1,500 a year, 5 a day. On one hand, it's an enormous effort. At the same time, it's nothing. So that also means that the production solutions you need are tuned to the fact that if you go from 5 to 10 aircraft a day, it's still nothing. Enormous amount of people work on it, but the repetition in the activities you do is not that high.
No.
So the lessons we have learned from automotive of making cans for Coca-Cola, that's a different lesson than what we have to do in aerospace. So what we have to do is more indeed, I mentioned ASML already earlier, but ASML is making unique equipment, unique equipment, and each equipment is probably fine-tuned towards the customer. But that's in aviation as well. There is not one single aircraft is the same. Even if you build 5 a day, I mean, there is already a difference, the one that you built in the summer and that you built in the winter. They are big. It's even the small aircraft is a big vehicle.
Yeah.
That means that if it is a metal one, let's say the metal one in the summer is a few centimeters larger.
Mm-hmm.
If you have to work on an accuracy of 0.1 millimeter or more, how do you do that? Now, those are the challenges we have to face. I mean, behind the scene, there are big challenges. It's easy to say, do more of the same.
Yeah.
The reality is we don't do the same. Every aircraft is different. They come from parts from all over the world. The assembly, it's a complex process. So what I think what we should do is invest in accepting that none of them is the same. And we have that technology today with the robotics and the AI, etc.
Yeah.
Make a factory that can adapt, that nothing is the same. that we have people there that accept that nothing is the same.
Yeah.
And that is a mindset that has to change.
Yeah.
But anything that is the mindset we need already, because AI is that already doing to our society. Anything that is repetitive or predictable, AI will take over.
Yeah.
Just think of aircraft maintenance, because you manufacture it once, but you fly it for 25 years. And every aircraft has a little bit different history in its making, but also in its usage. Maybe flies more in hot or in cold areas. Is more overloaded or less overloaded. So you should go with AI to maintenance schemes for individual aircraft, for individual airframes, for instance. And that is a possibility now.
Do you see in the course of the aerospace engineers we teach, is there AI courses coming in?
Yes, already in year 2 of the bachelor program, we already introduce AI.
Yeah.
And by the way, students already have knowledge about that. They use it massively.
And they should.
Yeah.
I mean, we as teachers have to adopt more.
It's here to stay.
students.
It's here to stay.
Yeah. So interesting. What are the academic topics, if you look at aviation, that are really promising? So AI is one topic. Are there other fields of research that's really promising to build aircraft?
How many do you want?
We adapt, right? So when I was studying, AI was not there. Now it's there. So we should adapt. But how can we use it in this high-tech environment? That's my...
I think AI was there, but you didn't call it AI.
No. Maybe that's true.
I mean, AI, on one hand, what it does is impressive. On the other hand, what it basically is just solving a set of mathematical equations, which we already did, I think, for I don't know how many centuries.
Yeah.
AI is just a slightly different rule set, so we have a different way of solving the equations. It means that the equations have to become a little bit simpler. So we can't always describe the problem as accurate as we are used to.
Yeah.
But AI, the way how we solve it is completely different. It opens new opportunities.
Yeah.
What you did at high school, or what people do at high school, fitting a curve, is already a basic of AI in certain things. If you allow that fit to change with the data, you're already at the basics of AI.
Yeah.
And we just now have the computing capacity to do that fast enough to make it interesting.
Yeah.
Is that allowed in aviation to let's say put our trust into a computer system, or?
Well, we do, because we do a lot of calculations, and that are part of the certification process of an aircraft. But still, you still need to do a lot of flight tests as well.
Yeah.
Flight test, ground test.
Yeah.
So it's a combination of, you have what they call means of compliance. You have a set of regulations, the airworthiness regulations, the big rule book.
Yeah.
And for every rule, you need to show that you comply with that rule.
And is that rule book changing accordingly into time, or is it like still the same?
No, that's an interesting thing. That rule book is more or less what we call graveyard technology. There are a lot of rules, and you can see that something went wrong, and then they invented a new rule to make sure it never happens again.
Yeah.
And a very interesting example, if you look in the rule book for general aviation aircraft, small aircraft, there is still a rule which says if you have a so-called gyroscopic instrument, that's an instrument like an artificial horizon that keeps your position in space, even if you're in the thick fog, that has to be adequately protected against the influence of weather. It's more or less what it says.
Yeah.
That comes from the time that they had open cockpits, and these instruments were there, and then when it started raining, the instrument broke down. But still the rule says it has to be adequately protected.
But did the rule change, or?
Yeah, that because that rule was made because the things failed, and then in thick fog people started crashing again. So it's graveyard technology, so it changes.
If you go back in these 10, 20, 30 years, so the reason why students choose for go into aviation, they change as well? Or is it still the drive of people want to study aerospace engineering?
Yeah, I think it has always been a wide range. What we don't see that much anymore is the people who want to become an astronaut or a pilot. Slowly but steadily, we've made clear that this is not the place to be for that type of wishes. You see, people fond of aircraft, fond of technology, fond of difficult things. Maybe the family was involved in aviation, in maintenance or piloting or whatever. There's thousands of reasons.
Maybe a shift in the transition towards sustainable flight. Can we call it sustainable flight? Or is that a hypothesis?
Maybe you call it less unsustainable.
Yeah. So what is the big elephant in the room talking about sustainable aviation?
It's bloody difficult.
Yeah.
It's a hard to abate sector, as they say. It's very difficult to make it sustainable. And that's because it's, from a technical perspective, very difficult because of the safety, because of the economic things, the cost, and also from the societal aspect, because people want to fly. They make our life in that sense more difficult by the fact that they fly more faster than we can innovate and implement new things.
Yeah.
For me, it's difficult to answer because I don't know. I mean, I have a feeling what I think what sustainable is, but it's a word that is misused
Yeah.
by so many. It has different meanings in the meantime. So if you talk about sustainable flight, I need to know what you mean with the word sustainable in relation to flight.
I think by asking the question, I'm looking for an explanation of that term, asking you that question. So what is sustainable? So in my opinion, like 10, 15 years ago, we were not talking about sustainable aviation, and now we do. But
yeah, but maybe, and what I very much like is to use the formal definition, the so-called Brundtland definition.
Yeah.
Invented in 1987 in a United Nations report, which says sustainable development is development that fulfills the needs of the current, but also it gives the opportunity for future generation to fulfill their needs without compromising the ability to do so. So there must be a balance in what we do and the harm we do to Earth, and the ability for future generation to also do what they want to do. That's about the balance.
Yeah. I've prepared to close this podcast 3 statements, and you have to choose.
Oh dear.
I did not give you the statement beforehand, otherwise...
I could find an evasive maneuver.
Yeah.
You want the fire alarm?
Yeah. Can we press a button here somewhere?
Yeah. No, but they're... I think they're okay. So the first statement for both of you is doing research or teaching?
I would say do teaching, because in order to do proper teaching, you need to do research as well. How about that evasive maneuver?
Yeah.
I was inclined to say research, and at the same time I was saying research, I said, but teaching in front of the class, there are much better teachers than I am. I'm sitting next to one. That's a much better teacher in front of the class. But teaching is more than just in front of the class.
Yeah.
If teaching a PhD, guy supervising a PhD, supervising a master student, where you get to that one relation, where you get a little bit more of the person, that is the highlight of my existence at academia.
Yeah.
So if that is education, then education.
Yeah.
But it is research activities we do with those persons.
Yeah.
But it's not about research. It's about the 2 persons together doing something that is unimaginable before.
Yeah. That the sum of parts is bigger than the...
Yeah. So I think it's education. It's the person.
Yeah.
It's the other person that is needed to make my life nice.
Yeah. Clear. Second statement is the technology is already here, or we need more time to do research on the future of that specific technology.
I would say a lot of technology is already there, or the basics are known. Making it fly, literally, is the challenge, and that takes time and money. So patience is required. Quite a lot we already know.
Yeah. And for you, Rinze?
I think most of the technology is there. In a sense, again, talking as an academic, a lot of work has been done. As an engineer that puts its signature under a document saying this is safe to use and this reaches the sustainability goals that we have set, we are far away from that.
Yeah.
And that is, those people still need a lot of help, also from us, but also from the remainder of society, including governments, that need to establish a long-term vision.
Yeah. Last question. Not fly at all, or fly consciously?
I would say fly consciously.
I fully agree.
Because it's a means, and maybe we had in the beginning the fact that you need to meet people, what Rinze said. That was also the reasoning behind what happened in 1944 at the end of World War II, why we wanted to stimulate aviation, the Chicago Convention, which says, we see that it's in order to achieve world peace, people need to meet and talk each other, be confronted with each other. And aviation is one of the means to do that. Well, you can see that works not perfect yet.
No. Thank you both for being in the podcast and sharing your thoughts on this topic.
Thank you for the
You're
opportunity.
Welcome. Aviation doesn't change overnight. It moves through decisions, trade-offs and time. And maybe the real question isn't how fast we can change, but how consciously we choose to. Thanks for listening to Coffee with Martin, and tune in for the next episode.